We've got another limit up on the board. Again, I'm going to suggest that you pause the video, try to work this one out on your own, and then tune back in and we'll go over it together. Welcome back. Okay, so we've got this rational function here. Now if I try to plug in 2, that's going to give me 4 minus 8 plus 4. Big surprise there, the bottom's going to 0. Okay, if I try to plug in 2 on top, I'm going to get 8 minus 16 is negative 8 plus 14 is 6 minus 6, so the top is also going to 0. Now, top and bottom are both just polynomials, so I'm going to try to factor. So we've got the limit as x goes to 2. Now the bottom is easier because I can do that one by inspection. That's x minus 2 squared, or just x minus 2 times x minus 2. The top's a little bit more difficult. I've got x cubed minus 4x squared plus 7x minus 6. You might have tried grouping, and if you tried grouping, I hope it didn't work, because it shouldn't work, okay? That 7 has nothing in common with any of the other pieces. There's no way I'm going to get anything else with a 7 involved. Okay, so factoring by grouping doesn't work. Here's where I need to remember something from pre-calculus. When we plugged in 2, we got 0. So that means I know that x minus 2 is a factor. And I can get the other factor if I simply divide this by x minus 2. I'm actually going to rewrite this and use synthetic division. So this was 1x cubed minus 4x squared plus 7x minus 6. Quick check, constants x squared, x cubed. So I've got my numbers in the right positions. For dividing by x minus 2, what I'm putting out here is 2, the number that I'm subtracting from x. If you don't remember the shortcut for synthetic division, you might brush up on it, or you might just do it as long division. Okay. All right, 1. 1 times 2 is 2. Add that to negative 4 and get negative 2. Times 2 is negative 4. Add that to the 7 to get a 3. Times 2 is 6. Negative 6 plus 6 is 0. Oops, sorry, is 0. There we go. All right, so I have a remainder of 0. It divided in evenly, and then this is code. That's my constant x squared. So my other factor is x squared minus 2x plus 3. I really don't see a nice way of getting this factoring without taking advantage of the fact that we know one of our factors. Okay, so now I can cancel, and so we've got the limit as x goes to 2 of x squared minus 2x plus 3 over x minus 2. Now this function is actually exactly the same as the function we started with, because even though I just canceled, I didn't change the domain in doing that. I still can't plug in 2, because look, the bottom is still going to go to 0. But let's take a look at the top. The top now is going to 4 minus 4 plus 3. The top is going to 3. So I have not gotten to a point where I can evaluate the limit by plugging in 2, because that's still not allowed, but I have gotten to a point where I can evaluate the limit. You want to recognize that. The idea is, if this function is the same as this function, and if that was even true everywhere except at 2, it turns out they're actually the same at 2 because they're both undefined at 2. Okay, but that means the limit here is the same as the limit here. I don't necessarily have to get to the point where I can evaluate the limit by plugging in. I just need to get to the place where I can evaluate the limit. And here, I can't, because the bottom goes to 0 and the top does not. So I know there's a vertical asymptote. I'm going to do a sign check. Just doing that off to the side. The top is close to 3, so the top is positive. The bottom, there I've got x minus 2. Well, if x is a little bit bigger than 2, that would be positive. But if x is a little bit smaller than 2, that would be negative. I don't have a consistent sign for this function, so the limit does not exist. One word of caution here. In order to get credit for telling me that the limit doesn't exist, you have to do this work and get to this point. If you got stuck and weren't able to factor, that's not evidence that the limit doesn't exist. That's evidence that you need to review and remember that, hey, if 2 makes the top 0, x minus 2 is a factor, and we can get the other factor by division. So you needed to get to the point where it was clear from evaluating and doing our sign check that the limit did not exist in order to get to this credit. Okay.